In the last video, I demonstrated a deadlock situation that can occur in a producer-consumer application. This happens when you have two synchronized methods on a shared resource. One process is waiting for the other process to do something, but it can't because the first process won't release the monitor lock. I've got the project up from the last video, the Consumer Producer project. Before I get back to the code, let's talk about a couple of methods I haven't yet covered that are on the object class. These are the wait, notify, and notify all methods, which are used to manage some monitor lock situations to prevent threads from blocking indefinitely. Because these methods are on object, any instance of any class can execute these methods from within a synchronized method or statement. I'll pull up the API documentation for object which, as you know, is the parent of all other classes. There aren't very many methods on the object class. Several of these you become very familiar with, like the string and get class. But there's also two others, notify and notify all here, and there's three overloaded versions of a wait method. I'm going to click on the very last wait method, the one that has two arguments, because it has the best definition of how these methods work. The key thing I want you to read is the third statement down. We're told that this method causes the current thread to place itself in the wait set for this object and then to relinquish any and all synchronization claims on this object. Think about that for a minute. The wait method will put the current thread in a wait queue, if you will, for the object it might otherwise have a lock on. This frees up the object's lock to be acquired by other threads while that thread is in this waiting state or set. If we read further, we find that the thread which calls wait will lie dormant until something happens. In other words, the thread that had the lock relinquishes the lock when it calls wait, but only until it gets woken up by some outside event. That event can be any one of the 5 things listed here. This list includes being notified by other threads that something's happened when those threads broadcast either a notify or a notify all method. I'll talk about this in just a minute. In addition to being notified, a thread could be interrupted. There is an overloaded version of the wait method which, if it times out, will wake up this thread at that point. The last condition is if the thread is awakened spuriously. That doesn't sound good. If we read further, we're told this is a rare thing, but we need to code for it. I'll cover how to do that shortly. Now, let's quick look at the notify method. This method, we're told, wakes up a single thread. But how does it know which one? Well, if we continue reading, we find that the choice is arbitrary. Arbitrary doesn't seem like a good thing either in application code, especially since the thread that has the lock probably really needs to be notified. I want you to think about this for a minute. If a thread broadcasts notify and there are 2 or 3 threads in the wait set, any of those threads might get notified, but only just one of them. So it might not be the one you really want to notify at all. It could be another thread completely unrelated to the process at hand. There are some good use cases for this notify method, but it's not what we want in our case. Now, I'll scroll down to the second notify method, notify all. This says that it will wake up all threads which are waiting on the lock or monitor. And even though it wakes up all threads, they can't acquire the lock before the notifying thread releases the lock. Okay, now that we know in theory what these methods do, I'll apply them to my consumer producer example. Any code in a synchronized method that's sitting in a loop and waiting for something to change should be calling the wait method. This will suspend its synchronization claims on the object while the thread waits for some condition to be met. In other words, it won't block other threads. This needs to be done in the message repository class in both the read and write methods where we have the while loops. I'll start with the read method. Inside the while loop, I'll call wait with no arguments. You might have guessed this will throw a checked exception, so I use IntelliJ's help to wrap it in a try-catch block. I'll also add the notify all call outside of the loop, and after this code toggles the message flag. This is the trigger another thread is waiting on. I'll next repeat this for the write method. I'll copy the try-catch block from the read method and paste it into the write method. I'll also add the call to notify all, again after this code toggles the message flag. let's just go through and discuss a few things about this code. First of all, we're still looping. Now you might be wondering, can we do this outside of a loop, maybe with just an if statement, for example? The answer is that you always want to call wait within a for loop. The loop should test for whatever condition this thread is waiting on so it can proceed and finish its task. When a thread is notified to wake up, it might not be because the condition it's waiting on has changed. Remember, notify all wakes up all threads that are waiting, so this thread could be woken up for a totally unrelated reason. If it wasn't in a for loop, it might not complete the task it's really asked to do. If there's no message, it should continue to wait. You should always call wait within a loop so that when it returns, meaning when there's been a notification of some sort, it'll go back to the beginning of the loop. At that point, it'll check the condition it's interested in and call wait again if that condition hasn't changed. So in other words, never assume that a thread is being woken up because the condition that it's waiting on has changed. This might not be true. The next thing here is, you probably noticed I called notify all. The notify method doesn't accept any parameters, so there's no way for it to notify one specific thread. It's conventional to use notify all unless there are many threads waiting and they're all set up to do the same task. In that case, you'd want to avoid waking up every thread because of contention and performance issues. In that scenario, calling notify will wake one thread. Because they all do the same work, it's sufficient to wake just one thread in that case. Okay, let's see if this actually works. I'll run this. And there I can see all the lines in the nursery rhyme followed by the finished message, so that's a good sign. I'll run it again. It's taking a second or two to process each message, but I'm consistently getting the finished message and the application exits smoothly. In this video, I gave you one solution to deal with the problem of a deadlock. This is to use wait and notify all methods in each synchronized code block, in this case the methods. Coming up, I'll be talking about other locking mechanisms and the pros and cons of using those rather than relying on the implicit monitor lock. First though, I've got a challenge for you, so I'll see you in that next video.